Let's apply our understanding of equilibrium concepts to solve a problem. In this problem, we are trying to determine the solubility of sodium sulfate, and we know the KSP value for sodium sulfate. Remember that KSP suggests or tells us that the reaction that we're interested in is the dissolution or the breaking up of the solid into its ions in solution. So we're going to make 2 sodium plus ions plus a sulfate 2 minus ion in solution. And we know the equilibrium constant for that reaction is 0.67. We must start every equilibrium problem we do by writing the reaction of interest. And because we have a KSP, we know that this is the reaction that we want to write. Now we need to understand what we mean by solubility. When we talk about the solubility, we're talking about how much of this solid can dissolve, is soluble in the water. So we want to know how much sodium plus and how much sulfate minus we get, because every sulfate comes from one of these. So if we know how many sulfates we get, we know how many of these have dissolved. And so in this particular equilibrium, we're going to start with enough sodium sulfate that we have some left over, so that we know that we've reached equilibrium. Remember then that when we get to equilibrium, we must have some of everything in our reaction mixture. There needs to be some of the reactants and some of the products left at equilibrium. So if we dump enough sodium sulfate into our water so that some of it dissolves, but there's still some solid left, we will have some of everything that's represented in our equilibrium reaction in our system. So we're going to start with lots of sodium sulfate, and then we're going to ask ourselves how much of that dissolves into solution. So this is our initial condition, so I'm going to label this as I. We didn't put any sodium plus in our beaker, so we have none of this to start with, and we didn't put any sulfate in our beaker, so we have none of this to start with. So our initial amounts of everything are that we have a lot of solid, and then we have water with no sodium and no sulfate in the solution. To get to equilibrium, we're going to have to make some sodium and some sulfate. How much of that do we make? Well, we don't know, and so we're going to give that a variable. So the next thing we're going to do is we're going to look at how does this change, so C for change, how does this change to get to equilibrium? And if we make X amount of sulfate, we don't know how much, so we'll just call it X. If we make X amount of sulfate, every time we break one of these up, we get 1 sulfate and 2 sodium ions. So if I make X sulfates, I have to make 2X sodiums. And then that has to have come from somewhere, and so I have to have lost, so minus, because I lost it, X amount of the sodium sulfate. So my change to get to equilibrium is that I break up X of these, so I lose X of the sodium sulfates, and I make X sulfate, and I make 2X sodium plus. So that means that at equilibrium, I'm going to have my whatever I started with plus whatever I've done to change to get to equilibrium. So at equilibrium, I'm going to have lots of this minus X, and I'm going to have 2X of this, because 0 plus 2X is 2X, and 0 plus X is X, so I'm going to have X sulfate. Now, I know that my KSP value is 0.67, and the expression for KSP for this reaction is the sulfate concentration times the sodium plus concentration squared, because I have 2 sodiums for every 1 sulfate. So I know that 0.67 is going to be equal to this quantity. And my chart, my so-called ice chart, tells me that I have X sulfate and 2X sodium plus. So I'm going to substitute my equilibrium values for the concentrations in my equilibrium constant expression. So that tells me that 0.67 is equal to X times 2X quantity squared. The sodium plus concentration is 2X, and I need to square that concentration. So if I work this out, this is going to be equal to 4, because 2 squared is 4, X cubed, because X squared is X, and then I square it, so I have X squared times another X gives me X cubed. So that tells me that 0.67 is equal to 4X cubed. And now I can just solve for X, and X, notice, will be the amount of sodium sulfate that has dissolved, and that is the solubility of sodium sulfate. So if I find X, I know the solubility of sodium sulfate. So to solve for this, I'm going to take 0.67 and divide by 4. That's going to be equal to X cubed. So I'm going to need to take the cube root of 0.67 divided by 4, and that is equal to 0.55 molar. And I know that it's molar because my equilibrium constants are always in terms of molar concentrations when I'm talking about solution phase reactions. So the solubility of sodium sulfate is 0.55 molar. So I will dissolve enough sodium sulfate in water until my concentration of sodium sulfate, or concentration of sulfate, is 0.55 molar.